Let's try to do some examples for projectile motion. On page 13, this one I will leave it for another video, so you can skip it. And let's take a look of, there are 6 examples here. So you may want to start doing it one by one and then listen to my explanations, or if you feel confused, then you may want to take a look of some of my like part of my workout, and then you can continue to do. So feel free to pause at any time. For the first question, I said it's launched with a speed, so this is u. So we'll still remember to maintain the habits that we have. I encourage you to do like previous video. And then it said for part ABC, they have different angles, so find the xy component of the initial velocity. So this is really simple. It's not even projectile motion. It's just a question about vector. So let's say for A, so we will have ux equals to m. In fact, if you remember what I said, then you should know u cosine 30, then that is, actually I could put it as 18, and then you can just use your calculator. And the answer is 15.588. So say we'll keep it as not 3SF, 2SF, so I take it as 2SF then. Okay, so meter per second. And then uy is simply 18 sine 30, and then again you use your calculator, it will be 9 meter per second. So similar thing, like it is in fact very boring. So for when you are 0 degree to the horizontal, in fact you can do much easier. So ux, because 0 degree to the horizontal means you have simply shooting it horizontally. So ux is simply u, which is 18 meter per second, while uy is simply 0, because vertically it has no velocity. For C, it's like the other way around, so 90 degree to the horizontal, so probably it's going to be like this. Alright, this is horizontal, so 90 degree with the horizontal, and so simply ux will be 0, while uy will simply be u equals to 18 meter per second. Of course, you may, if you really want to make it more like computer way or robotic way, you still try to plug into the equation. You can think about what we do here is like we do u, cos ux is cosine, right? So u cosine 90 degree, and then for uy for part C is like u sine 90 degree. And you should know that for u cosine 90 and sine 90, they each would equal to, for cosine it equals to 0, so that's why no matter what it is, it will become 0. And sine 90 is simply 1, so it will simply be equal to your initial speed, that is 18 itself, u itself. So that explains mathematically it will still be like totally valid. This is actually a pretty good question. Let's take a look at the next one. It asks you to sketch the graph for the variation of time of horizontal and vertical component of velocity for a projectile at certain angle above the horizontal. So one thing that you need to realize how to draw the velocity time graph. So maybe I would, in case it has any negative, so I would do it like this. But probably I don't think horizontal will have one. uy and then t. One thing you need to realize is when you want to, not u actually should do v, so more general velocity, is that you need to realize the slope again in the velocity time graph represent acceleration. Okay, slope in VT graph represent acceleration, and so in terms of acceleration, you need to think about the force, the net force acting onto the object separately, so horizontally and vertically. For horizontal, when you think about trying to launch a certain ball, horizontally there's no force unless you are saying there's air resistance, then yes, then you may have a different graph, of course. But here, I think at the beginning we'll just assume, even though the question didn't say, we'll assume there's no air resistance. And so for vertically, the only force that you have will simply be weight in that case. So it will be a constant value of 9.81, or you may call it 10, and that would be the acceleration. So since you have certain angle to the horizontal, then your Vx initial, or I should say initial horizontal velocity, it will be a certain value. So we'll start from here, and then in fact there's no acceleration. So according to Newton's first law that you learned, there should be no change at all for the velocity. So this is simply how it looks like for horizontal. For vertical, since you're launching it with a certain vertical velocity, then you should have a certain value. You can set it as negative if you want, but I think it's easier to set it as positive. And so you should have a certain slope, which the slope in itself, if you could calculate, of course now we are doing more like a qualitatively, then the slope should equal to 9.81. And you can imagine this is the uy, this is apparently 0, and so that means at this point the object is like at the highest point, because this is a turning point vertically, it starts to go back down, and where the velocity equal to 0, and then afterwards it will start to point downward with the velocity, so go more and more negative in that case. So I hope this can illustrate you how we can represent it onto the graph. Let's take a look of the next question. Is that a object is projected horizontally from a height of this. So horizontally here it means I suppose there's no angle, and then with a speed. So I think the best way to do this kind of question is you should draw a diagram. So here is an object, the height is 20 meters above the ground, so this is the ground, and then you have a certain velocity 15 meters per second. So this is how it looks like, and of course intuitively then you should be able to imagine like it's probably something like this, or maybe the curvature I can refine a little bit more. I think probably like this usually. So it's just an idea. So for part A, it asks you the time where it hits the ground. So this is a very good example. Think about this. Which direction of velocity would determine the time? Will it be both horizontal and vertical, or only horizontal, or only vertical? You can think about it. And the answer is that since horizontal, like the previous question, has nothing to do with when it will reach the ground, because if you think about when it hits the ground or reach the ground, it is really about your vertical displacement. In this question is simply 20 meters, because no matter how far you go horizontally, it has nothing to do with whether it reach the ground or not. Right? Of course you may say, oh, in a large scale, then since the world, the earth is round, then yeah, of course in that case then we can discuss it further, but then we are talking about in a normal scale. So whenever you talk about the time in projectile motion, you should consider the vertical motion directly. So what we can do is since uy is what, 0, and then a is, say, I'll just take it as 10. So one more thing is like what you do in the previous part, you have to define directions. I'll define downward as positive, so that would be a will be simply positive 10 meters per second square, and then displacement is 20 meters, and I want to find the time. So for this equation, apparently if you recall what you learned, I suppose the equation will be s equal to ut plus half at squared, and so you can substitute. S is 20, u is 0, so I'll just keep it as 0. I don't even bother to put down t. Half 10 t squared. So by solving on your calculator, you should be able to find t equals to 2 seconds. And that is for part A. For part B, let me use another color. horizontal distance travel. So now since you know about the time, how far it would take to reach the ground, and then apparently when you hit the ground, then the whole motion will kind of stop, right? Of course, I mean, you can again argue, hey, the object would hit the ground and then kind of bounce, blah blah blah, but then that will be another very complicated physics problem. So we basically would just call it an end by the time it hits the ground. So horizontal distance travel would simply be that since there's no acceleration, so you don't even need to do any kinematics equation you learn in IB, just use the normal equation, which is simply distance or displacement is u times t, but u here is referring to ux because we're talking about horizontal. T apparently is the same time because horizontal vertical share the same time apparently. So as x maybe I should put, to be more specific, it would be 15 times 2, that would give, maybe I'll write here, 30 meter. So that is part C. Sorry, part B. Part C, the speed it will hit the ground. So apparently when you are approaching the ground before it literally hit on the ground, you would have two components of velocity. One is of course the original horizontal velocity, which is I call it Vx, but then in fact this is also Vux as well. At the same time, you also have Vy, which would not be different, would not be the same as Ux, because apparently it has been accelerated, so it will be much larger. So our task should be firstly find out Vy, and then we can kind of combine it with Ux. Okay, so I hope I have enough space here. So in order to find Uy, then you can imagine I have one more symbol that is Vy here, and then I have to think about an equation that I could use. One I could think of will be this one. Of course, again, you can use any other equation that involve V. So Vy square equals to U, that is Vy was 0, plus 2a is 10, s was 20, and so by calculator you can find it is 20 meter per second. Okay, so but the thing is that we should not stop here, because it said the speed, that means that there's no direction, and it should be combining both horizontal and vertical when it hits the ground. So according to what you should have learned in maths or vector, when you're combining two vector, that is, say, imagined this is the vector, so one is 15, not in scale, the other one is 20, and so what I want to do is I want to find this slanted, the combined resultant vector. So how could I do? The easiest way to do is to kind of move this one of the vector to form a triangle like this. Okay, and then you can find this length, and that will be using simply Pythagoras theorem, and so therefore V should equals to root Vx square plus Vy square, that would equals to root 15 square plus 20 square, and then you can find the answer by using calculator, and so the answer is 25. So that means that when it hits the ground, it is hitting with a 25 meter per second. One more thing that you want to find, if only the question asks you velocity, that is, if you recall, velocity and speed has a difference, that is, velocity is a vector, and vector carry the information of direction. So in this question, we could really stop here after we wrote the unit. I almost forget. So then we can finish our job here. But then if they ask you about velocity, then you have to find out the angle. So maybe I can show you how to find the angle in case they ask you velocity. So the easiest way to do is you want to find the direction from the horizontal. So imagine this is the triangle. Let me zoom in, and let's say this is the angle you are talking about. So the easiest way to find this angle is simply again using trigonometry. Tangent theta in our case would be 20 over 15, and so you can simply use your calculator. Arc tangent 20 divided 15, you should be able to find 53 degree, 0.13 if you like to say. So that will be the angle that it is from the horizontal, and that will be the angle that you are striking the ground. Okay, if you're okay with all this, then you should be pretty familiar and comfortable with projectile motion, because the one that we just did is a very typical questions of projectile motion, and yeah, if you can do it, and you should be able to do the rest. Okay, so let's take a look of the next question. It said projected horizontally again with a certain velocity, and it asks you the vertical component after 4 seconds. So apparently you want to find Vy. This is V, and then T is 4. This is T, this is U, but then this is more like Ux. So because the angle is 0, right? So Uy is 0. And then let's not forget, question never tell you, but then you should realize it is on Earth. I mean, of course, if it is on Mars, on Moon, then acceleration will be different. But then apparently you normally assume it's on Earth. And then you want to find Vy. So again, you may want to find a equation. Apparently, I can simply use A equals to V minus U over T. So 10 equals to Vy minus 0 over 4, and so Vy will simply be 40 meter per second. So that will be part A. Part B, x and y component of the position vector. So it's like displacement basically of the object after 4 seconds. So you would want to find after 4 seconds. So apparently for S x, so horizontally it will simply be Ux plus T, because apparently like last question that I said, horizontally you have no change of velocity since there's no force and no acceleration. So you can just simply calculate the horizontal displacement by this method, like how you do in primary. And so that will be 12 times 4, that will be 48 meters simply. For Sy, it will be a bit more tricky, but then you just have to use the information here. So I think the easiest way to do would be using maybe S equals to Ut plus half AT square. And so Sy, notice that I put this S as simply S, but this one as Sy, because the second step is when I substitute. So S here and the original is more like a general idea, and here is a certain specific value which is represented by Sy, and U here should be Uy, which is actually 0, so I'll just put 0 here, and then A is actually 10, and then T is actually 4 squared. So Sy, by using, you can find that is 80 meter. Okay, so that is simply the answer for x and y component of position vector. Okay, this is somehow easier than the previous question. Let's take a look of the next question. It asks you about the maximum height. So whenever they ask you maximum height, you should recall that V is 0, like the previous parts of video. We talk about the one-dimensional kinematics. But here, be careful, since we are talking about a projectile motion, we should confine the so-called maximum height on the vertical motion. So it's not just V equals 0, but the Vy, vertical velocity, equal to 0. That is simply the key. So the rest should be easy. So let's take a look. It said it launched at certain angle with this u. Okay, so find the maximum height. So very simple. That apparently a this time they force us to take 9.1, then I'll take 9.1 then, and uy should equal to u sine theta, which is 25, because this is the original total speed. So 25 sine 32 degree, and you should be able to find the answer from calculator. That is 13.25, let's say. Okay, I'll try to take more decimal place because this is the intermediate step. And we got A, we got U, and then we want to find SY. We also know that Vy is 0. So by looking at this, apparently the equation that you want should be V squared equals to U squared plus 2AS. Once again, the U and V here I put as a general symbol, but then later on I would narrow it down to Vy. And then Uy is actually 13.25 square plus 9.1 S. Oh, sorry. Vy is actually known to be 0. S is the one that we don't know. So, like this. So, by solving it, you should find 8.94x with a negative. So don't worry if you find out you have a negative value. Think about why it is negative. Alright, if you follow through like all these things I do. Because apparently when I do define A, I do define it as 9.1 positive. Alright, if I don't say it. So that means I defined downward as positive implicitly. And apparently we have actually, I think I make a mistake here, because it is launching upward, right? Like this 32 degree, right? So I think, oh, maybe I think it's fine, because at the end you have square. So here I have a negative. In fact, I forgot to make a negative here, because it should be pointing upward like that. And then you have a negative here, substitute into it, but then since it's square, so it's gone anyway. And then eventually you still have mathematically a value of negative 8.9 for SY. And this is simply because when you simply launch it like this, then the so-called highest or maximum height will be 8.948 meter, which is upward. So apparently this will be negative in that case. So your answer would simply be fine as negative 8.9. I mean, having a negative value here. Okay, so don't worry about that. You of course, I will strongly encourage you to think twice about it. Okay, last one. We have launching horizontally again. And now the height is known, so SY is this one. It hits the ground with a velocity that makes, okay. So kind of reverse engineering, I guess, to the horizontal. Find initial speed, initial velocity of the launch. Okay, so 9.8. So you could draw the diagram as in like this, 42 meter, and then you somehow launch horizontally, so like this. And then it makes an angle of 55 degrees. So say this is the vector V finally, and so then the angle is 55 degree. Yeah, I think that's just all. You also know that UX is unknown. Initial velocity. Oh, that UX is simply what you want to find, but then Y is 0, because again it's shoot horizontally. It's shot horizontally. So let's start to do it with maybe how we said earlier. So perpendicularly, or vertically, actually I should say vertically. Then we know UY is 0, S is 42, A is 9.8, I will take downward as positive, and I want to find UVY, because at the end of the day you need to use the information of 55 degree, which is related to Vy and Vx. So we want to find Vy, and from that we will be able to get the equation, I guess, that V squared equals to U squared plus 2AS. So Vy is the one we want to find. U is 0 to 9.8, S is 42, and so Vy is, using calculator, 28.69 meter per second. Okay, and then we have to do it for horizontal also. So horizontally we have Ux to be unknown, and actually we should take a look of these first. So we have 55 degree where Vx Vy will make 55 degree like this, so that is tangent 55 degree equals to Vy over Vx, and since we know Vy is actually 28.69, then we can find Vx. So Vx using calculator should be able to find out by 20.089, so I guess it's 20.01 maybe, or simply 20 if you like to. So then we know Vx is, let's just keep it as 20. So Ux is what we want to find. A is in fact, wait, then that will be it, right? Because horizontally there's no change of acceleration, right? So then,
oh my god! Wow! Oh my god!
What you find for Vx is in fact the same as Ux. So the answer is simply which is U, which is 20.01. Right, if you want to write, or simply you can round it to 0. That's it.